Hi, Fabio.
Brandon, how are you?
I'm good. What are you doing here?
Looking at this EEG, and I'm not sure if I'm going to call it normal or abnormal.
Oh, is this the fighter pilot?
It is.
So I heard about this. Let me get this right. He was going to the bathroom, between flights, I guess, and then his companion heard a thump, found him unconscious on the floor, and the question is this syncope or a seizure?
That's
Is
right.
that right?
That's correct.
Okay.
The EEG looks
Well,
pretty good, except for this guy up there, and I'm not really sure if it's normal variant or it's the real deal.
hmm. It's sometimes tough.
Yeah.
Well, how do we decide whether that's an epileptiform discharge or not? You know, a benign variant or something less serious.
It's a great question. I think there are some criteria for it.
Aha! You nicely numbered them here for us.
Right. Makes it easier. All right, so these are the six criteria that we use to classify a waveform as epileptiform or not epileptiform. Number one here is the morphology of the suspicious waveform. So if it's spiky or sharp, it gets 1
Gets
point.
one point. Yep.
Yeah.
Yeah. And number two is the duration of the wave. So it should be different from the duration of neighboring waves, like those guys. Yep.
Okay. All right.
1 point if that's true.
Three is the symmetry of the wave itself, comparing the upgoing and the downgoing slope. So if it's asymmetric, it gets 1 point.
Yep. And then four is simply, does it have an aftergoing slow wave? If yes, it gets 1 point.
And then five is whether it disrupts the background or it stands out. I think this gray example represents a waveform that does not, that would not disrupt the background. So if it does
Right.
disrupt the background, it's 1 point.
Yeah.
Okay.
And then the sixth point is for whether it has a physiological field that suggests a source within the brain.
Okay. All right. And how many points do we need?
You need 4 out of 6 points to sort of be considered probably more likely than not to be an epileptiform discharge.
Okay. Perfect.
That's our convention.
Love it.
Why don't we go through these one by one?
Okay. So let's start with number one there. It's morphology. So what does that mean, really?
Right. So the morphology is simply if it has to have a morphology such that if you sit down on it, it will poke and hurt your rear end.
Ouch.
So it has to have a spiky or sharp morphology. This one that you're showing here clearly does, right? You wouldn't want to sit on that.
It's true. It's pretty spiky. Does it matter if it's a spike or a sharp in terms of being epileptiform or no?
No, either way is consistent with a risk for seizures.
Gotcha. Okay.
Left temporal discharge in this case. All right, so that's number one. Has the right morphology. At least this one does. We'll decide about our pilot at the end.
Okay. Go back to it. All right.
Our second criteria. Right. So the wave duration, is its width different from the width of the background.
Okay.
So let's take a look at our example again. In this case, this one is in some ways maybe too easy. This width, if we can compare this to the neighboring waves, I mean, there's really no question that this is a different thing than neighboring ones. But let's look at this little wave, for example. That it is its duration different, maybe a little different. Here's a wave. It's different from this. It's a little different from this. I mean, so maybe we'll have another example where it's more of a question, but sometimes if the wave looks very similar to the neighboring waves, except for it's a little taller, you can decide, well, actually, it's probably just one of those, just another one of those things that we see everywhere else. In this case, it's so different in its morphology that we don't really even have that question.
Gotcha. Do we have to have the duration lasting longer or shorter, or
just has to be different?
Different.
Yeah, could be longer or shorter.
Shorter.
It just has to be, not fit in very well. Has to be a bit of a misfit.
What about this guy?
Oh yes, this is a conveniently good example. This wave right here, or these ones over here, right? These little guys, these little sawtooth. This one is a little pointy,
Mhm.
Maybe that would hurt if I sat on it, if I sat down kind of hard on it.
True.
But so maybe morphology, it's a questionable, but in any case, the duration of this wave is very similar to the neighbors, right? So this one is about the same.
Mm,
This one is about the same.
got it.
This one is, all the neighbors look about the same as this guy. So it's probably just another one of those with slightly different, morphology and amplitude, but it doesn't stand out in terms of being, different.
Gotcha. They're all cousins. They look
They're
so-
all friends. Yeah, they're all,
Okay.
these guys hang together. Criteria number 2, it does not pass that.
So let's keep going. So that's just the same example, but on
Yeah.
reference.
Yeah, I think you can see even more clearly that this is just one of it's just part of the ongoing background activity, not really, not different in duration.
Gotcha. Again, because the duration is similar, right?
Yeah.
Okay. So what about number 3?
So number 3 has to do with the slope, right? So for epileptiform discharges, typically they will have different slopes for the upgoing and downgoing part. So in this example, maybe the upslope, it looks to me like that's steeper than the downslope. Now the criterion is not that the upslope has to be more steep than the downslope. It's just that the two slopes, when you compare them, are not identical, right? So
Gotcha.
I guess a little triangle would, that's not a good triangle, would not satisfy that criterion.
Gotcha.
If they're symmetric in their slopes, it does not satisfy criteria 3.
Got it. Okay. So let's take an example, or back to our example. Yeah, they're
Yeah,
pretty
I mean, I would say this looks pretty similar to the one we just drew here with the
right.
upslope. Well, actually, which do you think is steeper?
I think this one is steeper, the upgoing.
I think the upslope is steeper too.
Yeah.
If you see it down here in the, look at the chain down below. Actually, that one seems to make it more clear that the upslope is steeper than the downslope.
So that qualifies.
Yep.
Now, number 4 is just whether
the presence of a slow wave.
Let's take a look at an example. I think that one's pretty straightforward, right?
Yeah. Here there is a clear slow wave.
Yeah.
Now, of course, spikes or epileptiform discharges don't always have that. So again, if you see it, it makes it more likely that it's a real epileptiform discharge. If it's not there, you could satisfy 4 of the 6 criteria. So some of the other criteria.
Got it. Okay. It's just because if you think of a spike, I think this is what comes to mind, right?
If you were going to write a textbook, you could put one like this in there.
Yeah. Awesome. Okay. And then that's number 5.
Yeah. So number 5 is that it stands out from the background.
Right.
So I guess the example shown here is one, not standing out from the background so much. It's kind of just continuing on with maybe what was going on before.
Right. Okay.
So this is kind of similar to criteria number 2, but I think it's more about the whole complex. Does it look similar to things that you're seeing repetitively, or is it a distinct event?
Gotcha. Okay. Let's take a look at back to our example here.
I mean, this one, it just jumps right out at you, right?
Yeah.
There's no things similar to this in the surrounding EEG.
There's no cousins, just only kids.
Right. Now, I guess this criteria could be problematic if you have just, if all the background is epileptiform discharges, then, it's hard to say what the background is in those cases. But
6 is just whether it makes sense, where are they coming from in the head, right?
Right. So this is to help us distinguish sharp transients in the EEG that might be coming from, for example, something not in the brain, like an electrical artifact, or maybe a muscle artifact, or some other non-brain origin.
So it's left temporal chain up there. I was just looking at the 10-20 system montage up there, and if we look at the left temporal chain, it makes sense that it's coming from the same area of the brain, right?
It's not just sort of on one electrode, right? This is involving a broad area in the left. So it involves C3, T3. You can see it in T1. Yeah.
That makes it easier.
So yeah, so you can see, so it's maybe maximal in either, well, yeah, I'd say T3. You can see it's similar in T1, which is nearby.
Right.
And then, but it has field to T5 and F7. So
Right.
this makes sense anatomically, because if you look, those channels physically are, near
Nearby.
T3. So if we imagine that it actually, originates somewhere near, underneath the T3 electrode, it's involving this cortex in the neighboring regions as well. That supports this being a real discharge that originates in the brain.
Gotcha. Right. So I guess the other idea, if we have negativity, for example, at T3, and then you also have negativity or seemingly negativity coming from F8, it wouldn't make sense because there's nothing in between or pretty far apart. Does that?
Yeah, that would be weird, right? That wouldn't make sense.
Okay. So I guess the field is just that it's not weird. It kind of makes sense, right?
Yeah, right.
Okay.
And they should, in almost all cases, the epileptiform discharge should be pointing up, right? Should be negative, on the referential or average montage.
Sounds good. I think those are it, right?
Let's go back to our pilot friend and let's see what we conclude. So if we go through, we go through our criteria. I'd say, criterion number 1, is it spiky? Yes. I mean, that's what caught our eye.
Right. Okay. So 1 point.
Number 2, is its duration different from its neighbors? I think no.
Yeah, I don't think so. Okay.
Number 3, the slope, is the upslope different from the downslope? I think the upslope is a little steeper than the downslope. So I think we could probably give it a point for number 3.
Okay, so 2 points.
Number 4, it has no slow wave, so no point there.
Okay.
Number 5, does it disrupt the background? What do you think?
I would say no. Overall,
I would say, yeah, I think debatable. I mean, if it didn't disrupt the background a bit, then how did we even notice it, right? But
true.
But yeah, it's not super different from the background. Yeah, I guess if we just focus on the most pointy wave right there, this guy is maybe. So can we find any? I mean, it's maybe a little bit like this one? I don't know. I think this one is kind of debatable.
Okay, let's give it half a point there.
Give it a half a point, yeah.
For 5. Okay.
5, and then 6. Does it have a field?
Kind of does, eh?
Yeah.
Okay.
It involves neighboring electrodes.
Yeah.
So what do we get? How we give him
3.5.
3.5.
Oh,
right on the border.
Tough.
This is a tough call when we're unsure. Don't call it, right? So that's a philosophy which errs on the side of, false negatives,
Right.
but avoids false positives, which that has some advantages.
Right.
Of course, if we're wrong, then we could be sending a pilot up who might have a seizure and crash the plane. And
should we repeat an EEG? See what it repeat shows?
Yeah, that's always an option if we have a sort of equivocal finding. This is the only example of this finding in this EEG. Is that right?
The only one, yeah.
Yeah, I think I agree with that idea. Why don't we recommend repeating it and just describe this as a finding of uncertain significance? I think this is probably just what we call a wicket spike, but it's the reality is that sometimes we really are uncertain, right? And so although we force ourselves to say yes or no, the truth, the deep dark truth is that we don't know for sure.
It's true. Okay, that's the beauty of it.